Hello friends, it's another fun episode of Math the Night Before a Quiz. And I'm going to be doing this practice quiz. And I'm going to hopefully help you with any parts that you are unsure of. What I'm sure of is that at some point my dogs are going to bark or something horrible is going to happen that's loud and annoying. And we're just going to live with it. Okay, so arithmetic, keep in mind that means that there's a common difference. So that means you're going plus or minus, adding or subtracting to go term to term. Geometric means there's a common ratio, so you're either multiplying or dividing to go term to term. Neither means neither. So keep in mind that term numbers are the counting numbers, 1, 2, 3, 4, 5, and so on. So the first thing I would check is if something's arithmetic or geometric because that's easier. So for example, in this first problem, I can see as I go here that I'm multiplying by 2. So I'm going to have a geometric option, and it's going to be an R value of 2. So over here it wants the next 3 terms. So I'm just going to continue to do that pattern since I already know that it's ending at 16. So I'm going to have 16. I'm just going to multiply that by 2. And I'm going to get 32 times 2 times 2 and so on, except for it just wants 3. So I'm not going to go so on. Just kidding. In the next one, it's not obvious to me what's going on. So what I can do is I can check for like a common difference if I'm going to go arithmetic first by taking any term and subtracting the 1 in front of it. So if you do 11 and a half and you subtract 13, you get negative 1.5. Then you have to make sure that that continues to be true. So if I take the 10 and subtract 11.5, that is also negative 1.5. If I take the 8.5 and subtract the number in front of that, it is also negative 1.5. So I have a common difference, and apparently as I go, I'm subtracting 1.5, making this arithmetic. It means I have a common difference, and it's negative because the numbers are going smaller, 1.5. So then I would just take my 8.5 and I would take away 1.5 because I just follow the pattern. Then I would take away 1.5 from that. And then I would take away 1.5 from that, and so on, without the so on. So the next one, clearly, like from here to here, I would have to be adding 8, and then that's not working because it's going back and forth. When it's going back and forth, then it's sometimes geometric, and it would mean that my ratio is negative. If I'm trying to figure out the ratio and I can't figure it out just by looking, I can take any number. So in this case, the 6, I don't know why it's not drawing, sorry, over the number in front of it, and it gives me negative 3. Then I take the 18 over the number in front of that, and I get negative 3. 54 over the number in front of that, and I got negative 3. So a common difference, you can take any term minus the term before it, and the common ratio, any term divided by the term in front of it, and then just check that that's consistent. So this one's also geometric, and it has a common ratio of negative 3. So 54 times negative 3 is going to put me back at a negative number, but then when I multiply that negative by negative 3, it goes back to being a positive number, and then times negative 3 again is going to put me at a number that hopefully will fit, negative 1, 4, 5, 8. Okay, so all of these are either geometric or arithmetic. Because I don't know and can't guarantee or promise, mostly because I can't remember, if there was something that was none, it might be something like, let's say I had 3, and then 6, and then 11, and then 18. And I'm trying to figure out, like I'm thinking really hard right now, because I'm trying to figure out what is that tie. There's not a consistent value to divide, like 6 divided by 3 is 2, but 11 divided by 6 is not. So there's not a common ratio. The space between 3 and 6 is a 3, but the space between 6 and 11 is a 5, and here to here is a 7. So there's not a common difference. There's not a common ratio. It's not arithmetic. It's not geometric. It is neither. I can follow the pattern, and my next number looks like be plus 9 because the numbers that I'm adding are going up from 3 to 5 to 7. So I would imagine the next number I add is 9. So 18 plus 9. Then I'd probably add the next odd number, which would be 11. Then I'd have to add the next odd number, which would be 13. And so then I'd be at 51. Keep in mind that pattern, that up by 3, 5, 7, 9, and so on, indicates a square. So if I had to write like an explicit for something like this, then I would have to look at, okay, this is n squared. But if I actually square these, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Each of these numbers up above that are my actual terms are 2 bigger than my squares. So I'd have to add 2. And we did this way back a couple weeks ago in 8-1. So just watch for that pattern because we've seen it several times. Okay. So here's what we're going to do explicit formula, keeping in mind that the explicit formula, I'm going to write my formulas down here. If it's arithmetic, my explicit formula simply is this guy that we've used repeatedly. And if I'm doing geometric, my explicit formula looks like this. And if I'm doing neither, I have to figure it out myself. So looking at this, these are a repeat. See that? The first 3 are the same. So I already know that this one's geometric. So I know that I'm going to be using my formula A1 times the common ratio to the n minus 1 power. Alrighty, so my formula starts with A sub n equals. My first term, I can just look into the problem and it's a 1. Common ratio, I already found up in problem 1 to be a 2. And then n minus 1. And you don't multiply the 1 and the 2. Because if you did PEMDAS, which is like a real math thing, always will be, the exponent comes before multiplying. So you can't do the exponent since there's an n up there, but it certainly can't be multiplied. The base doesn't multiply by the 1. You don't have to really write the 1 because it doesn't mathematically change anything. And then to do 35, I just have to plug in 35. So on my calculator, I'm doing 1, and then in parentheses, 2, raised to the, and then 35 minus 1 is obviously going to be 34. Now, I got a big, huge, humongous number, but that's because I'm raising 2 to the 34th power. I got 1.72-ish, and then I got that E10, which means 10 to the 10th power. And that's okay. Numbers get really big, really fast with geometric. Okay, how about this next one? I'm, again, using number 5 goes with number 2 from up above. So this one's arithmetic. So I think, okay, my arithmetic formula is A1, and these are going smaller, so it's going to be minus D to the, and then n minus 1 after that. In particular, I'm going to have a first term of 13 minus 1.5, and then times n minus 1. But when we learned these, we learned that we have to distribute and combine. So if I go ahead and distribute that, I'm going to be at 13 minus 1.5 and then plus 1.5 because the negatives here will cancel. So my final formula for my explicit is going to be, oh, there's an n in here, negative 1.5 n and then plus 14.5. And when I plug in a 35, I get negative 38. Okie doke. So the next one, again, is a repeat from number 3 up above. So I know from number 3 that this one is geometric in nature. And I'll be taking A sub n equals my first term, which is negative 2, and then my common ratio, which I found up above to be a negative 3, to the n minus 1. And again, really important that you can't multiply the 2 and the 3. You can't cancel the negatives because this part is going to be positive or negative depending on whether it's raised to an even or odd power. So you do not ever multiply these two numbers together. You leave them. So that's my formula. Fits on this line where it doesn't actually fit. And then here I'm going to be plugging in 35. So I'm going to have negative 2 times negative 3 to the 35 minus 1 or 34th power. So negative 2 in parentheses, negative 3 raised to the 34. I don't like messing with the minus 1 up there. I like to just do it in my brain. And so I got negative 3.34-ish. And then I look and it's times 10 to the 16. Go through this on your calculator. Make sure that you are able to figure that out. Now, this next one is a newbie. It's not from up above, and it also is not arithmetic. Oopsies, not arithmetic or geometric. So I have to think, how is the top and then how is the bottom related to my n, meaning my term value? So I'm going to create a little space over here. I can see that the top numbers are equal to my terms because this is 1, 2, 3, just like I'm at 1, 2, 3. So that means that the beginning of my formula is that the top number is the term number. The bottom ones I can see are going up by 2. So back when we did this, we said that means you're doubling the n and then you make any adjustments. So if I doubled my 1, I'd get a 2. If I doubled my 2, I'd get a 4. If I doubled the third, I'd get a 6. And then looking up here, each of the numbers I'm getting is 1 shy of what I need. So my adjustment is going to be a plus 1. So that's my formula. And now to do a 35, I'm going to have 35 over 2 times 35 plus 1. So I end up with 35 over 71. So this is a neither, and that's where you have to really use your brain power. Okay, now it wants recursive. So think about what that is. Recursive has to tell me the first term, maybe even the first two if they're both involved, and how to get the rest. And then I have to have a separate equation, so more than one equal sign, telling me what to do to the previous term. Maybe I'm going to add, maybe I'm going to subtract, maybe I'm going to multiply. This is where I start, and then this is what I do to move term to term. So you have to look at it like this. How do you get from 5 to 9 to 13 to 17, not at all tied back to the term number? Well, I can see that I am adding 4. So the first thing you have to tell somebody in order for them to build this accurately is you have to say, hey, the first number is 5. Start with a 5. Then to get any other term, take the previous term, that's our n minus 1 notation down in the subscript, and then you add 4. So this part is always, always, always a part of my recursive formula. And then it's just a question of, in each particular problem, where do I start? 5. What should I do? Add 4. This one is tricky. We've seen some like this before, but you got to be a thinker. Sometimes, and in this case, like we've seen in a couple worksheets, you got to think kind of hard, but also look for patterns we've already seen. The pattern that I see is that this 3 is the sum of the two previous numbers. This 5 is the sum of the two previous numbers. This 8 is the sum of the two previous numbers. So here, the rule is going to be, hey, you need to take the number right before it and then add it to the number 2 before it. So you're adding up the two previous terms. But if that's the case, you can't just tell them the first number. You're going to need to tell them the second number as well, so that in order to get the third space filled, they can add up the two previous terms, because you told them, hey, the first number is a 1, second number is a 2, and then the next number will be the sum of those. Looking at 10, I can see that I'm multiplying, everything's getting twice as big, but I'm also seeing a negative, positive alternating. So this is saying, hey, my first term is 5 again, And now to get any term, you're going to take -2 times the previous term. So just like up above, I had to say what the first starting number was and then give my previous term as a part of the formula. That's in a part of my formula every single time I do recursive. Here I was telling you where to start, and this part is telling me what to do. Start with 5, multiply by -2, keep on going. Up in the top one, start with 5, add 4, keep on going. Middle one, first number is a 1, second number is a 2. To get the next number, add them together. And every time you want to find a spot, add the numbers right before it together. Okay, this bottom part is going to be a big brain kind of thing. You need to look at this rule and decide if it's arithmetic, geometric, or neither. Arithmetic has to be linear, like mx plus b. This is not. Geometric has to have n in the power. This does not. So this is going to be a neither, which means there's not a shortcut. There's not a formula. I have to grind it out. This is the first number that I start with for plugging in, and this is where I stop. So I'll need to find the first term by plugging in a 1. Then I find the second term by plugging in a 2. So that's 4 plus 3. Then I'm going to find, hang on, I'm turning my computer on because I like to multitask. Then, actually I don't like to multitask. Then I'm going to find my third term by plugging in that 3. So like this part never changes. All I'm changing is this. And it's saying go from 1 to 5. So then 3 squared plus 3 is going to be 12. 4 is going to be 4 squared plus 3, so 19. And I stop at 5, not because I'm sick of doing it, which may also be true, but separate issue. I stop because the top number was 5. And then a series adds all of these terms up. And when I did that before, I got a 70. So that's actually the answer. When it says evaluate, you're looking for the value or the number of that sum. Okay, this one I'm hoping I don't have to plug in manually because there's 57 terms. But I see this and I think, oh, that's mx plus b form, so this is going to be arithmetic. So I'm going to bust out my arithmetic formula, knowing that I either will know everything I need to know or I will have the opportunity to find it. So this is starting at 1 and going to 57. So I am actually using all of the terms. So I have 57 terms to plug in as my n. To find my a1 value, I go to the formula and I plug in 1, which is 1. Then to find my last value, I'm looking for my 57th because that's the top or stop number, and I would simply plug in a 57. And so I did that earlier and got -233. Then I'm putting that entire thing into my calculator. I'm doing 1 plus -223. Oops, that should be a 2. So I actually got -223. Can't read my own writing. So the sum of the first 57 terms is -6,327, which is nothing more than doing that formula out on my calculator. Alrighty, zoom. I look at this equation and I see that n is in the power, and so I decide that this is geometric. This goes to a number, not infinity. So I use my geometric formula. It's a geometric sum formula. This one can definitely be tricky. So I am currently going to be adding up 10 because this is starting at 1 to 10. So I'm adding 10 terms. I need the first one. Well, like always, to find the first term, I plug in a 1. 1 minus 1 is going to give me 4 to the 0 power. Anything to the 0 power is 1, but the only thing affected by the 0 power is the 4. So I end up with a first term of 5. Then the formula says to do 1 minus r. R is always the thing raised to the power. So in this case, it's a 4. And the power is how many numbers I'm adding up, which is 10. And then on the bottom, 1 minus my r value again. So I talked about this a lot, that this is hard to do on your calculator. So I would do this part first. Oops. So I go to my calculator and do 1 minus 4 raised to the 10th. And you're going to get some kind of crazy numbers. So I have the 5 out front. I'm getting this. And again, don't just copy what I'm doing. Get your calculator out and give it the old try. 1 minus 4 on the bottom, I'm just going to do in my head. So then I can divide that number while it's on my calculator by a negative 3. And then I get this. And when I multiply that by the 5 that is waiting out front, I get this. And if you feel like, well, that's too big, that's probably wrong, you are adding up 10 terms. So it's not impossible, especially when you're doing 4 to the 10th power and then multiplying that by 5, it's entirely possible. So the last kind that we learned, so there's one of each kind, you guys, not by accident. We learned where you have to just grind it out, like in number 11, and plug in all the numbers from the bottom to the top. We learned that if you can recognize it's arithmetic, you can use this formula. We learned that if you recognize it as a finite, meaning it ends at a certain number, geometric, you can use this formula. And here with infinity, you have to check, what is your r value? Well, it's whatever's in the parentheses getting raised to the power. And since that's less than 1, you're good to go. Otherwise, this wouldn't have a sum. So the formula for an infinite number, as long as the r value is less than 1, is the first term over 1 minus r. And if you're doing it on your calculator, make sure that you tell your calculator that entire bottom is on the bottom. So my first term, like it typically is, if you have this n minus 1 power, I'd be putting in a 1 for that n. So that would turn into the 0 power, making this all 1. So this is my first term. And then on the bottom, I have to do 1 minus r, but r is just the number raised to the power. And if I do this on my calculator, I'm going to end up with a decimal, and I don't really want a decimal, so I do math, enter, enter, and I get 10/3. Because a decimal can go on forever, whereas a fraction is the exact value. Okay, so half of the fun. Let's do the back. Oh, we had a little typo here. We meaning me. So this is going to be a 7. Alrighty. So this leads you through a series of things that you're supposed to know how to do. It says it's arithmetic. So be thinking about your arithmetic formulas. Don't just like try to copy or memorize. Like have a sense of what to do and when to do that. The only time you use a sum formula is when they're talking about or asking about a sum, a total, sigma, something like that. And it's arithmetic. So these are my arithmetic formulas. They are telling me these 2 fun facts. I am supposed to find the common difference. That is not a sum. So I'm not going to use the sum formula. I'm going to use this one. But I don't, now I'm looking, this goes from 12 up to 62, so I must be adding numbers to get bigger. If it was going down in value, I would be using a negative D. All right, so I know A17 and I know A7. I know I'll be adding a common difference, 17 minus 7 times, because you're looking at the space between them. So to get from the 7th, world's worst arrow, to the 17th, I would need to use the common difference 10 times. Alrighty, so now let's put some numbers in that we know. We know the 17th term is 62 because it says so. We know the 7th term is 12. We do not know the common difference, but we're smart enough to know that 17 minus 7 is 10. So solving that, take away 12, divide by 10, I find out that my common difference is 5. So that is no longer a mystery. Now I need to find A1. Finding the first term has nothing to do with sums. Nothing in here says add, total, sum, sigma, nothing. So again, I'm not going to use that. I'm going to use this formula. I need to start somewhere and end somewhere. This is always, where did you start? What term did you end with? So since I'm looking for A1, that's going to be my unknown. My common difference is no longer unknown. I found it in part A. I have to go to an end, and the only two ends I could use are these. And since the 7th term is faster, I'm going to go ahead and get to that one. And if I'm going from the 1st to the 7th, then this is going to be 7 minus 1 or 6. You're saying, okay, I am going to use a 6 here. Hang on, my kiddo is calling me, so I'm telling her that I am making a video. She probably wants money anyway. So what is the 7th term? Looking up above, it is 12. Don't know the first term. Do know the common difference, and I know that it would take 6 steps to get from the 1st to the 7th. So I end up with 12 equals A1 plus 30. So A1 is going to be negative 18. Then what's the next thing that they're asking me for? Explicit formula, also not a sum. So I'm going to use this guy again. A sub n, which I leave as a general thing when I'm doing the formula. I now know A1. I now know the common difference. And then to get the formula, I distribute and combine. So distributing, I'd be right here. And combining, my formula is going to be A sub n equals 5n minus 23. That is my general formula. I can use it for anything. So to show my work to find the 59th term, I can now just plug in 59. So 5 times 59 minus 23. I am currently going on my calculator. And I am getting 272. Okay, then we're going to repeat that entire process except for geometric. So now my general formula is going to be a little bit different. And I'm going to just look up on the board and be like, okay, now I'm talking about geometric. Uh-oh, I told you we'd have barking dogs. Hang on, let's go yell at them. That's my really annoying little dog. Hey, Penny, I am making a math video and you are super annoying. If only this was a video and you guys could see her. She's super excited to be just ruining all the fun. Okay, before I was so rudely interrupted, here we go. I have to find the common ratio. Alrighty, well, I'm going to use the same approach. I know that 7th term, I know the 3rd term, and I know that to get from the 3rd to the 7th will require to use my R value 4 times. So what is the 7th term? 729. What is the 3rd term? 9. What's the common ratio? No idea. What's 7 minus 3? 4. So I divide by 9, and I end up with R to the 4th equals 81. So I can 4th root that bad boy, and I find out that my R is 3. Good, now I know that moving forward. Now I need to figure out A1. Okay, well, A1 times the common ratio that I just figured out will get me to, and I have 2 numbers up here. I'm going to use A3 because it's the closest. And if I'm going from A1 to A3, I'm only going to be using my R 2 times, 3 minus 1. So let's plug in some numbers. What's A3? 9. What's A1? No idea. That's what I'm trying to find. Already found the ratio, and I'm going to use it 2 times. So what do I know? I know that 3 squared is 9. So if 9 equals A1 times 9, my first term must have been a 1. Just solving for A1. Okay, explicit formula. Well, the explicit formula for geometric is first term times the r to the n minus 1 power. No distributing, no combining. So in this case, my first term is a 1, which I just found. My ratio is a 3, which I found before that. And my power is n minus 1. And I just leave it. And then to find this, a sub 15, I'm just going to plug in a 15. So 1, which really mathematically doesn't do anything. So in the end, I'm ultimately going to just be taking 3 to the 14th power for this one, because that number out in front is a 1. And I'm getting this kind of obnoxiously big number, but that happens a lot with geometrics because stuff gets bigger faster. And then this is just something I've talked about over and over, sequence and series. Sequence is going to be a list of terms. So like 1, 2, 3, be creative, get your own. And a series is going to be a sum. This is the key word. This is a list, this is a sum. Here you just list them, here you go ahead and add them up. So I would have 1 plus 2 plus 3 and so on until whatever that last term is. So that's a lot of things, but you can do it. I believe in you. I will see you tomorrow and we will celebrate our knowledge.